So today's lesson is about line and rotational symmetry. So after today, you should be able to identify and solve different types of symmetry. So let's start with our two definitions for this lesson. So line symmetry is a line that divides the shape into halves that match when the shape is folded along those lines. Okay, so let's talk about that. So if I were to draw a line across the middle here, then obviously that would be the same if I folded it over each other. And the same way here, right? That would give me the same shape when I folded it over itself. Now, if I were to draw this line and I flipped it up, then they would be the same shape, right? And here too, they would be the same shape, but that would not create the same shape. In other words, we've got, if we were to flip it up, it's not going to create the same shape if I just fold it along that, right? So those green lines do not create line symmetry, whereas the red lines do. Now, if we talk about rotational symmetry, it's a shape that can fit onto itself more than once when rotating around a center point. So basically, we're going to take a point in the center like this, and we're going to start rotating this. So the only rotation that here is 180 degrees. So like if we had this as side A and this is B, then if we rotate it 180 degrees around, then obviously B becomes A and A becomes B, right? And if we rotate it again, that would be 360 degrees. So we're not going to go that high, but this would have one rotation, okay? So when we're talking about regular polygons, that means the sides are the same. So here we have some the examples of identifying the number of lines of symmetry and degrees of rotation. So when we have a regular polygon, again, that means the length of the sides are exactly the same. Then the lines of symmetry equal the sides, the number of sides, okay? And with, again, a regular polygon, the degree of rotation is equal to 360 degrees divided by the number of sides. Now I'm going to show you one of these first right here on the right with this regular hexagon right here. So this is a regular hexagon, right? That's a regular square because all sides are congruent. So what that means is for both of these, that when we rotate them, then we're going to do the 360 divided by the number of sides, okay, because these are regular shapes. The trapezoid is not a regular shape. You should be able to see that the top and the bottom are not the same length, and the two sides may or may not be the same length as the top, but we definitely know that the top and the bottom are not the same length, okay? So the trapezoid is not a regular polygon. So on the trapezoid, where could we draw a line that creates symmetry? It would have to be straight down through the middle, right? So there's only one line of symmetry. And if we were to think about this shape, there's no rotation except 360 degrees, which is going to land the shape on its side, on itself, right? So that's 360 degrees there. Now, when we talk about lines of symmetry for the square, again, because all the sides are the same shape, we could cut it in half, right there, in half there, and again across here and across there. So how many lines is that? 4. And it had 4 sides, right? So that's what we were talking about before, because it's a regular shape, all the sides are the same length, then if it has, the lines of symmetry will be equal to the number of sides. Now, degrees of rotation, we're going to take 360, and we're going to divide that by 4, and when we do that, we get 90 degrees, right? So what does that mean? That means every time I turn this 90 degrees, it lands on itself, right? So that is our degrees of rotation. Now, the regular hexagon, again, all of these sides are the same length. They don't really look that way in this drawing, but we're going to say it is. So once again, we could go down through the middle, right? We could go down through the side here, or we could go across. Y'all see these? The sides like that, okay? Those are all going to create the same, and I haven't drawn enough yet, so through the middle, through the middle, through the middle, through the middle. But basically what we're going to end up with is 6 lines, right? Because again, if it's a regular shape, a hexagon has 6 sides, so let's count. 1, 2, 3, 4, 5, 6, and ultimately when you get done, you should have 6 lines. So again, it has 6, because it's regular, lines of symmetry, and we're going to take the lines of symmetry, 360, and divide that into 360. So that would be 360 divided by 6, which is 60 degrees, okay? So let's see if you guys can do these 3, and then come back to me when you're done. So here again, it's a regular pentagon. So again, because it says regular, we know that the lines of symmetry are going to be 5, right? What are we going to do for the degrees? We're going to take 360 divided by 5, and that's going to give us 72 degrees. Again, regular decagon. If you don't know what that is, let's count. 1, 2, 3, 4, 5, 6, 8, 9, 10, right? Okay, so what are we going to do? This got 10 lines of symmetry because, again, it's a regular decagon. And then the degrees of rotation, we're going to take 360 divided by 10, so that's going to be 36 degrees. Okay, this last one looks to me like it's going to have a line that would cut it there and a line that would go through those points of that arrow. Those are the only two lines of symmetry. So if we have two lines of symmetry, again, the degrees of rotation are going to be 360 divided by those lines of symmetry. So this is going to be 180 degrees, right? Which makes sense, right? We'd have to flip it all the way over to the other side to get our degrees of rotation. So now you guys need to finish the worksheet and